Hello grade 10s, welcome back to another video. So today we'll be doing a velocity time graph. So without wasting any more of your time, let's get right into this video. So guys, a person riding a bicycle, right? So we are going to assume east is positive. So let's have this is west and this is east. So this person is riding the bicycle. He starts to ride from zero velocity. So we'll take velocities like acceleration, right? So this person starts at zero and then starts accelerating. Here he's working at 1 meter per second, 2 meter per second, 3 meter per second. He's accelerating now. So when they are going up, it's acceleration until they get to 4. So the acceleration rate is 4. And when they get to this point, they start decelerating. Now starting to drive. Now starting to drive slow from a positive 4 acceleration speed going down to 2, 1 until they get to 0, right? Now, when under where we have negative answers here, no, it's a different direction. So they were going towards the east. Now they are accelerating in the negative direction, west. So here, acceleration in negative direction. So here, which is west, because east is positive. So whenever under this negative, or when it reaches 0, here the acceleration is 0. When you're going down and accelerating again, know that this is now a different direction from this one, right? And if there was a person who was starting from north, which means it's south this side, or if the person was going from the right, this is still the right, but this is now the left side. No, just under this line here, we now have a totally different direction from the one that the person started. So the person starts with this direction assumed here. Always know that. So acceleration in the negative direction west is from here going down, and here the person is still riding the bicycle but at a constant velocity of negative 4. So when they ask you what is the position of that person at 10 seconds, still riding towards the west but in a constant velocity of 4 from 10 to 15. So the acceleration at this point is the same. The velocity is the same. This person is still walking even on this line here. Just know when we have a straight line, they are still walking, but at a velocity that is stated this side. So here it's 0. They're accelerating to going up, and then their deceleration to go down, and then accelerating again in a negative direction. And here they are just walking or riding at a constant velocity. But if there was a line from here going up here, they were also decelerating as well. You see, from negative 4, negative 3, negative 2, they are going to 0. So it's a de-acceleration from here to this side. So always take note of that. And you can also be asked to calculate the acceleration for the first, let's say calculate acceleration for the first 5 seconds. So which means from here, this part here. So acceleration, we are going, the formula for acceleration is change in velocity over change in time. So this is velocity final minus velocity initial all over time final time minus initial time. So in this example, our final velocity here at, we starting from 0, this is the initial velocity time, this is the initial time for this graph, and it's also the initial velocity for this one. So we're starting at 0, that was initial, and we're going to 4, that is the final. So here we'll have 4 minus 0. This is where we started, this is where we ended. And then the time is also, we started at 0 and end at 5. So we'll have 5 minus 0. And then you punch that into the calculator. That's 4 minus 0, it's still 4. 5 minus 0 is still 4. So 4 divided by 5, that will give us 0.8 meters per second. East, we got a positive answer. So east, we have assumed that east is positive. If there was a negative answer, if it was 0 minus 4 and 0 minus 5, we would have gotten negative answers. But no, wait, so it was going to be negative and negative. So those negatives were going to cancel each other. Yeah, it was still going to be positive. So we have an answer positive east. And then another thing you can be asked to calculate, they will say, what is the total displacement for the 15 seconds? Displacement is from beginning to end, right? When we are doing, a person walks for this direction and then comes back, this is the displacement. The difference is the displacement. But with graphs, displacement are quite different, especially with the velocity time graph, is that when you have a shape like this and you're asked, you need to calculate areas. So when you're talking about displacement, we're talking about area, right? So when we check here, we have a triangle, and then here we can cut it here and also have a at 10. 10 is exactly at this, and then you can have a rectangle there, but this is A, this is B, and this is C. So we are trying to calculate the displacement. So we are going to start with the area of this triangle. So with the area of this triangle, here we will have 7.55, or they can say, they can give you this or show you how to calculate it. Now what we're gonna start with, it's the area of this triangle. So area of a triangle equals to 1.5 breadth times height. So the breadth will be from here to here. That is the breadth of the triangle. So we'll have 1.5 7.55 times the height is from 0 to here, so it's 4 times 4, and that will give us 15 meters. And then or 15. Hey, 15 meters squared. That will give us 15 meters. And then we need to calculate the area for this triangle as well, which is B. And for that triangle also, triangle B, we have 1. And whenever you ask to calculate displacement for a velocity time graph, this is what you do. So you identify the squares, the triangle, the rectangles that you can get in there. So with this one, we have 0,75 minus 10. So from here to here, we have 2.5. So that is base 2.5 times the height. Here is the height, that's -4. And then you punch that into your calculator, and that will give you a -5. This is the area here. 2.5 times 4, and then half of this, or let's say 1.5. 2.5 times 4, that is 5. And then for this part, we have a rectangular, it's not a square, so that will be a rectangle. And rectangle area equals to length times breadth. So the breadth is from 10 to 15, and that is 5. That is the breadth. And then the length is from 0 to 4, -4, sorry, times -4, or you can swap them around. This is for the length and this is for the breadth, or you can just say -4 times 5 if you're following that exactly the way it is. So -4 times 5, that is a -20. Yeah, that is a -20. So for displacement, we will take the area, which is 15 for the first triangle, and then we say +5, don't mind the negative, plus, so 20. So we just add that together. 15 plus 5 is 20 plus 20, so we'll have 40. So that is our displacement. And then another thing that they can ask you is, what is the total distance for the 15 seconds? So guys, I made a mistake. This is the distance. So we have to calculate the displacement. This is for the distance. So when they ask you for the distance, you add these areas together. But when they want the displacement, you will say so the answer will be 15 minus the 5 minus the 20 to get the total displacement. So 15 minus 5 minus 20, that will give us -10. Because east is positive, then we'll get -10 west, and this will be total displacement. Thank you very much for watching, guys. Until the next one, we'll be doing acceleration time graph.